In this video I'm going to explain you how a Tesla coil works and how you can build one for yourself. Before anything else, let's explain the basic principles behind the Tesla coil. Hi, let me explain how a Tesla coil works with this old schematic that I drew 1 year ago. So as you can see, we have a high voltage generator here, then we connect it directly to a series of capacitors. Then capacitors charge up and release their energy into the spark gap, so that creates a strong magnetic field in the first coil, and that magnetic field generates a voltage in the secondary coil. So let me show you the real setup. Now I disconnected the ZVS driver so we can look at the low voltage side of the Tesla coil. So what we have here is the microwave oven transformer right there that I modified it so it can produce lower voltages instead of 1000 volts, and I use it to feed this bridge rectifier that's connected to this smoothing capacitor right there. So let's measure the voltage of this thing. It got several middle taps so I can change the voltage, but now I am using 26 volts AC in input. So let's change my multimeter to DC metering mode. Yeah, now let's check the output of the bridge rectifier right there. So that's 37 volts DC. As you know, it gets multiplied by the root of 2 when you convert AC to DC. So now we are going to connect the ZVS driver and see how it works. Now we are looking at the high voltage part of the Tesla coil. What we have here is we have the ZVS driver right there, and we got the flyback transformer right there. So what does the ZVS driver do? It creates a really high switching AC current to feed the flyback transformer. It got 5 turns in here with a single middle tap, then another 5 turns, so it got 3 terminals at the output that goes to the flyback transformer. What a flyback transformer is, if you're asking for, it's a transformer with several primary coils, but as you can see we are not using them, we are using our own turns in here. So this thing has a really high number of turns coil inside of it. It multiplies the voltage really high, then it converts it to DC one more time because it has several high voltage diodes inside of it. So we get high voltage DC out of this and use it to feed the actual Tesla coil. So let's turn it on. Now I got the positive terminal and the negative terminal of the flyback in my hand, so I'm going to turn it up. It will create a huge arc, so be ready for that. Let me reach the power button. This will be a little bit dangerous. Now it's actually opened. So let's see. It's a really hot arc and it's actually burning the cable down. Anyway, so let's close this up. And you see how the flyback transformer works, and it smells because of this burned wire, whatever. So now I'm going to connect it to the capacitor so you can see how it's. Well, this is my homemade high voltage capacitor right there. Normally it's connected to the flyback outputs, then it's connected to the primary coil of the Tesla coil, but I'm going to show it later. So first of all, let's check the capacitance of this thing. It should be 10 nanofarads. I made several prototypes for this, but most of them failed, and this was the best option I had, so I'm going to go with this guy. I'm going to set my multimeter to the capacitance mode so you can see the actual capacitance of this thing. I'm connected to the first terminal, and the other one is right there. It's a little bit far, so it's hard to reach, but alright. It's hard to hold it with one hand after all. Damn it. So there we go. Oh, it actually, I shouldn't touch it, so you can see. Yeah, we got 10 nanofarads, around 10 nanofarads. It's not actually 10 nanofarads, I know it, but it works. This capacitor will be connected to the flyback coil, as I said, so we can test the coil. Now we are seeing the primary coil, the secondary coil, and the toroid that I built and the base of it. So I'm going to connect the capacitor to the primary coil, put everything together, then I will show you the operating footage of this Tesla coil. By the way, let me get my tools. You can see my bike right there, that I modified it so it has LEDs and a horn underneath it, but anyway, this video is not about that. I got this, then I will look for some tape, if I can find, where is the tape? Oh, there it is. So I will show you the coil gun that I built. It's right there. Now we are ready to work. As you can see, everything is connected right there. We got our flyback transformer that's connected to the ZVS driver, that's connected to the bridge rectifier, and that's connected to the step down transformer. So everything is ready. As you can see, our Tesla coil is finished. It got the primary connections done, it got the ground wire going on, and we are ready to fire up this thing.